Now that the weather's improved some, I've been doing a little bit of work outdoors on my antenna system. You'll see in the picture here up on top of this mast on the left here, my 5-element beam for 2 meters and 432. The other two poles there hold a dipole I've made. It's based on a G5RV Junior, which is for 40 meters and up. I found that it loaded on 80, but not very efficiently, of course. And so I made some extra length here and made it 102 feet like the G5RV normal dipole would be. But I left the twin lead the same length as the Junior, which is 17 feet instead of 24 feet. And I wanted to see if I could run it that way because it is a little more convenient on the feed line for me. So I found that the 102-foot length didn't quite resonate properly on 80 meters. It was more like 4 megs or a little bit higher. So I did a little recalculation and lengthened it on each end a little bit. And this is the results that I came up with by doing that. Okay, we're going to do a few calculations here. I found that with the 102-foot length, I was resonant at 4.2 with the G5RV Junior length of twin lead. I can't make it any longer because 28 feet would not fit in the space available. So I left it at the 17, I think it is, feet, and decided to lengthen the antenna itself a little bit to see if that would do the job. So I found that it was resonant at 4.2 megahertz. So let's enter that. Divide that by where I want it to be, which is 3.9, the 75 meter band, and that's a 1.0769, call it 1.08. Is the times the length that we need. So when that times the current 102 length that I increased it to get it on 80 meters in the first place, means we want to have about 110. So let's take that, subtract 102. And that gives us 7.84. So 7.84, almost 8 feet. So 6 feet on the side will give me enough to play around with the length a little bit. And should resonate this thing down in the 3.9 megahertz region. So let's see if that's the case. When I lengthened this out to 102 feet, plus the extra that we've added to it, of course, I didn't fit on the roof anymore. Here's what I did in the front. Comes out to the corner of the garage, which is out in front of the house, and then jogs to the left there, and it's tied down. Then on the back side of the house, I came out to the 2 poles you saw that were sitting on the deck roof, and then jogs over here to a board that I've stuck out from under the eaves. We, of course, tested it using the MFJ-945E Antenna Tuner, which has an inductor, a transmit capacitor, and an antenna capacitor to tune things. The entire system, of course, depends on the feed line, the antenna tuner connector, any normal coax used between it and the transceiver, and the coax going up to the balun that's used to get currents off of the feed line, which is just loops of coax cable. And so all of that makes up the antenna system, if you wish. Then I can tweak and tune using the 945E. The mini circuits ZFDC 20-5 directional coupler is what I use to check the return loss, hooked up as shown here, and the Rigol DSA815 with tracking generator spectrum analyzer. So that's what's used for this. Now I've already hooked up my test unit here. Output goes through a 6 dB pad up to the spectrum analyzer over there, the tracking generator port. This side is a 3 dB pad that is on the coupler port just to set the coax here to a good 50 ohms and prevent any measurement errors due to impedance variations there. I put an adapter here that I can screw the antenna on from my radios over here. Or actually from the MFJ mobile tuner, which I'm using here. It's a model MFJ-945E and seems to do a pretty good job, so that's the one I'm going to use. And we'll take a look at it after I get it hooked up. But there's a couple of things we need to do first. First, probably best to have the radio turned off. Either disconnect the microphone, or the other alternative is I'm on HF right now. I can also, just for safety, put it up here on 144 megahertz. That puts it on a separate antenna, which is the UHF VHF antenna. So that also prevents transmitting into anything like an open load. So I think we'll be fine. And again, turn the radio off. This is the model MFJ-945E that I'm using. It has a transmitter capacitor here, an antenna capacitor here, and it has an inductance selector here. So these are taps on the inductor. And that's what's used to tune this thing to the correct resonance. We'll take the standing wave bridge here, or should we say, in this case, a directional coupler, and we'll hook this up to the cable here that's going to the antenna. So this is totally out of the circuit here. Make sure this thing's down good and rock it a little bit to make sure that we're making good contact. So now we should be good. I'll just drop that down there. And as you see, when I have a button here also that I can put in the tune position, or I can unpunch it and it's in the straight through position. So that's what that is. This is for a light, which I don't have power to this for turning the light on. But anyway, so that's how this thing works. It's fairly straightforward, nothing terribly unusual. So let's see what it does. I've got the thing in the out position here, meaning that it's going straight through. And we'll take a look on the spectrum analyzer and see where this antenna is presently resonant. As you can see, we're resonant about here. And this is with the button out, so that is the antenna's resonance. However, I haven't really set this up properly because we're not calibrated. So we have the tracking generator on, it's at 0 dBm, but we need to normalize it. So press this, punch normalize until it sets a reference, but that's no good because I just referenced it to the antenna. I need to pull the antenna off the end of the cable over there so that we reference to an open circuit. You notice what happened here. We get the opposite now of that resonance curve, and that's because it's compensating to that curve as being an open circuit, which I now have, and so it's looking the opposite of what it really is. So what I'm going to do now is to compensate this by turning off the normalization again, turning it on with nothing on that port. Now we're at 0. Now I notice this is at -30, I want to have that at minus 14, which is 1.5 to 1. So I'm going to move it up to minus 14. You do this by system, display, and display line is set to minus 30, as you see. So we'll go minus 14 dB. So now that's 1.5 to 1. Everything needs to be below that for a good match, although a minus 10 is a reasonable match. Probably won't fold back your circuit, protecting the antenna, the final. So that's what we're going to aim for here. Now I'll hook it back up to the antenna and see what we got. Okay, now we have a curve. I can find out where it's actually resonant here by hitting peak and minimum search. Minimum search will find the lowest point. So we're pretty far down, like 12.94, almost 13 dB. Not quite as low as 1.5 to 1, but still fairly decent match at 3.926 megahertz. Well, one of my favorite frequencies is 3930, so that's pretty close and pretty good. But let's put the markers in the various points. So marker 1 we're going to put at the 10 dB point on this side, so let's put it there. All right, yeah, that's not quite 10 there. And then number 2 we'll put to, well, let's just go with peak minimum search. All right, so that's at minus 13. And then we'll go and hit the marker again and go to number 3. And we'll move that one up to the other 10 dB point. So there you go. So we actually have a range here of resonance for this antenna by itself of 3.870 to 3.998 something, 980. So 3.70 to 3.980, about 20 kilohertz. And I can use this antenna without the tuner over that range, obviously. I've zeroed in on the screen here so that we can see what happens when I punch in the antenna tuner itself. Normally F with TX at 5 and RX at 2 will match at this frequency, so let's see if that actually works right now. I'll do that. So actually, I had to modify it somewhat, or adjust it somewhat, and I ended up with the antenna being at 3.3, and the excuse me, that would be the transmitter at 3.3, and the antenna side capacitor at 2.2. But as you see, we have a very good match. It's much better than 20 dB at 3900. Obviously, we've gone up a little bit here on the 10 dB point, so we'll have to, it's narrower because it's higher Q, so we'll take 3 down to 10.22. And then we'll go back to 1 here, get it down to 10.05, okay. So now we're we're seeing 3.88 to 3.97 as our resonance. As you see, higher Q, therefore narrower bandwidth, but of course it's adjustable. So if I want to go to number 1 over there, I can do that. Let's do that. And that would be good enough. It's 20 dB. That's a very low standing wave, 1.11 or something like that, 1.21, something like that. But I can also adjust the antenna side and adjust that to where it tunes nicely. Or I can go up to the other frequency. And there we go. So we have a very good match at 3.97. And I can actually go up to 4. Let's go up to 4, which is the edge of the band there. So there's 4. We'll put marker 4 on 4 megahertz here. There you go. So we're at 25 dB there, and that's pretty darn good. What you do is you check your band in the areas that you want to work. You're only running about a milliwatt here maximum getting to the antenna, so you're not going to create any great interference by doing these measurements. And you can go across each band and record the settings of your inductor, your antenna, and your transmitter capacitors, and make a chart, and then you can post the chart next to your rig somewhere. I have a little laminator, so I take it and I laminate it and then I hang it on a hook. But anyway, you can be set up, and you can also play games. On some bands you can probably get the entire band by adjusting carefully the two capacitors, the antenna capacitor and the transmitter capacitor. I know that on 17 meters I put it at 0 and I think it's 2.5, and it covers the entire band up there, no problem, even though that band is not normally self-resonant. So it takes a little bit of skill to learn how to do this, but it's helpful because you can like I say, make yourself a chart, and you can at least start at the right settings and adjust carefully from there, because there may be differences with rain and so forth and so on. So I guess that'll do for the moment, and if you have any questions, go ahead and give me a question on the site and I'll try to answer your questions.